Uh, anyway, so let's go ahead and get started. My name is Brian Mitchell. We're here to talk about big data on Azure. So this is a 200 level session, just a level set with you guys. There's not going to be a bunch of demos. I'm going to be pointing you to other deeper sessions that you might find on some of these subject areas. What I'm going to talk about is more of a higher level, level set about how we're thinking about big data at Microsoft and how we think that the Azure platform can help you achieve those things. If that's not what you're expecting, now's probably the time to find something else. Otherwise, we're going to kind of roll through a ton of services in Azure, how you might go about using them, and I'll be happy to take some questions as we go through it. I don't mind, answering some questions as we go through. Just raise your hand, and I'll try to get to you. So let's go ahead and get started by stating the obvious. Shit's gotten real in the last couple of years. Data management and data management and using data has completely changed. When I first started in this space in the late 90s, the guide that I got from an Oracle DBA was that data is a good place to be because things don't change very often. It's not like having to learn a new programming language every couple of years. And that's because before about 2010 or so, when we talked about data, we were talking about down in that left-hand quadrant of ERP and CRM systems, right? Generally, when you talked about data management, we talked about human-generated data. And this data came from your payroll systems and your inventory systems and your sales pipelines and what have you from CRM systems. We generated data by humans. And it wasn't until the late 2000s that we started seeing Web 2.0 data being actually not only generated, but then actually used by organizations. And that's where things like Hadoop and what have you came along. So people started looking at web logs and recommendation engines and e-commerce and how they could take advantage of that data. And it was a fairly complex world to try to merge that data with the ERP data. But data has continued to accelerate for us. And so as we talk about big data today, we're talking about additional data, your clickstream data, your log files, additional third-party data like weather data, and trying to mash that up with the original ERP data that you might have had. So when we talk about big data, we're talking about all these different data types coming from different systems and trying to figure out a way to augment that original data, that ERP data, your customer data that you might have, to make it more valuable. That growth of data has really been generated from mobile and cloud. And if you're in an organization today where you're not taking advantage of a lot of mobile and cloud data, if you're still basing your data off that ERP, human-generated stuff, then you're missing an opportunity to really differentiate your organization from other organizations. So when we talk about the modern data ethos, what we're actually talking about here is taking that data that you have, that you've generated from cloud and mobile and other digital devices, and merging that with that analog data that's been born of your other systems. And what that allows us to do is get to a place of data abundance, where we're able to take that data, instead of focusing on your transactional systems and thinking about ETL and OLAP and enterprise data warehouses, where a lot of us are still stuck today, looking at how we can start, getting to the place where you're doing operational reporting, interactive dashboards, ad hoc analysis. Oftentimes that's done on top of tools like Hadoop. This operational reporting allows your end users to, really have a better idea of what's going on today. What's going on right now. The interactive dashboards allow them to drive into the data instead of it being limited down to the X and Y axis that we've defined for them through some sort of reporting. And then, of course, just allowing them ad hoc analysis, allowing them some sort of space where they can access the data without having to go through some sort of tool so that they can go find what's important in the data and maybe create some new operational reports in their interactive dashboards. But really where we want to get to, and the journey we all want to take, is that upper right-hand quadrant, where we start using machine learning of any data, and possibly in memory so that it's quick. And so when you see demos by Joseph Sarosh and Satya talking about all these amazing things you can do with AI and what have you, you need to get there by kind of following this path of getting away from ETL and OLAP and start building on top of some sort of big data platform so that eventually you can get to the right-hand quadrant. What we're going to talk about a little bit today is how to the tools that you can use to build that platform to eventually get to that right-hand quadrant. Also, technology is changing. And what that means is, beyond the fact that data's changed and there's all sorts of new data that we can use, technology itself is changing. And we can talk a little bit about how the traditional data warehouse has changed. So who here has worked with traditional data warehouses, some sort of general data warehousing? So we all know this kind of stack of you have your data sources, you do ETL, it gets loaded into a data warehouse, and you set some sort of BI and analytics on top of it. That's a fairly standard system that a lot of us build. But it's getting a lot of pressure because of increasing data volumes. So we start talking about, all right, we've gotten into the terabytes range, and a lot of us can deal with dozens, if not hundreds of terabytes into a appliance data warehouse. Who here can manage petabytes of data in a data warehouse? Who wants to manage petabytes of data in a standard appliance data warehouse? The increasing data volumes become a problem. They just become a problem from an ETL standpoint. Also, we have asked for real-time data, right? So lots of organizations are asking for better real-time data. And so we've done that by, instead of doing daily processing, we've gone to hourly processing or every 15 minutes processing. We really haven't gotten to real-time data. We've gotten to real-ish time data. We've basically got faster batch we've oftentimes created for our customers. And our customers being the reporting and analysts that are looking for this data. What did they do in response to IT basically coming up with faster batch? A lot of times they start setting up their own systems. And you're starting to see this more and more in organizations where no longer does IT have control over all the data because the impatience of the business groups have gotten to the point where because we can't give them real-time data fast enough, they've just gone and built their own systems and they've circumvented the IT shop and the traditional data warehouse. Additionally, we also have new data sources and types, right? And I could beat you over the head with all the different data sources and types from devices and webs and sensors and social. I think you guys know that this data is out there. The question is, how much are you taking advantage of it? Are you doing anything with it? Is it just dropping into some place and then you're not augmenting your original data sources with it? Is it because it's too hard to do in your traditional data warehouse? Oftentimes it is, because taking a lot of that data is sitting in JSON or XML or some other data source that makes it more difficult to get into your traditional data warehouse. But we need those data sources to really truly be doing big data and to be doing intelligent actions on our data. So we'll talk about how to get that data in. And then finally, cloud-born data. Data that's born in the cloud, whether or not that be web logs or something else. That data is also very important to augment our solutions. So a modern data warehouse looks a little different. It has your traditional relational data warehouse there on the left, but we also try to look at the additional big data tools that are built to handle that non-relational data. And instead of trying to shove it into our traditional data warehouse, we're going to be better off by trying to use systems that are purpose-built for dealing with that kind of data. So when we talk about a modern data warehouse, we tend to think of several different systems going side by side that we can merge the data. The way I like to think about it is that let the data tell you where it belongs, not the other way around. Don't try to fit every square or round peg into your enterprise data warehouse, but let the shape of the data determine where the data should live. And that may be in the cloud, that might be in some sort of big data store like HDFS. It might be in some sort of JSON store like DocDB. And we'll talk a little bit about that. And then, of course, after that, we need to enrich our data using some of the data quality tools, and then finally have some BI and analytics on top of that. Some of the tools we'll use for those things you'll see over there on the left, things like the Hortonworks Data Platform. We'll talk a little bit about SQL Server 2016, of course, or the APS appliance. But also in the cloud, we'll talk about Azure Data Lake and some of the other additional solutions. All that's because we're trying to make this move to this hyperscale world. And so enterprise IT, traditionally, we've kind of had these things where we talk about, relatively low level of seats to where we're talking about millions of seats possibly. Supply chains where we try to get more strategic. Infrastructure where we try to become the enabler, not the overhead. When we talk about availability, instead of trying to build additional infrastructure, we try to figure out what services we should use. The cloud allows us to move from this enterprise IT mindset to this more hyperscale mindset that allows us to really start focusing on these business questions and bringing in this additional data. Finally, culture changes also. Different groups start asking different questions. Engineering teams are starting to ask questions about their services that they build, for example. Oftentimes when they add additional features into a solution, one of the things that we do here at Microsoft now is we start thinking about how do we track whether or not a feature is successful. And we do that by putting that into the data. So everything that we build data around that, and we capture that so that we can see how often a feature is being used. And so that we know when we look at it and we try to evaluate the additional features that need to get done, when people go, oh yeah, well that feature is really important and we need to add additional resources to it, we can look at the data and look at it and say, well wait a second, hardly anybody's actually using it. I know it's really important to you, but none of our customers are using that particular feature. Is it really all that important? And vice versa. A lot of times we'll put something in that we don't think is really going to change the world, and then we'll find out that a good percentage of our customers are using it. Feature engineering and putting data around your features in your applications is really, really useful. But how do you capture all of that data? When you talk about a company the scale of Microsoft, we're talking about hundreds of millions of devices. All that data is being captured, and we'll talk a little bit about that. Marketing, oftentimes marketing wants to know more data about their customers, how they can improve revenues through observing their customers better. Observing your customers is finding every piece of information you can about their customers and putting that in. The more data you have from different sources, the better information you're going to be able to drive. And then, management, field support, lots of different questions about culture. Everybody's asking more questions about their operations, and they want to be able to do this by driving it through adding more data. Let's talk a little bit about how Microsoft's changed and how we've gotten here and how that's kind of driven the services that I'm going to talk about through the rest of the talk. Let's start by talking about a really big data problem, an ocean of data. And that ocean of data is actually the internet. It is everything, every website that happens on the internet. It's every interaction that happens on the internet. And really thinking about that big data problem. In that particular case, you're processing billions of documents, billions of entities, trillions of relationships. It's just a really large big data problem. And Microsoft, has tried to solve this over the years. And when we tried to originally solve it, back in the 2000s or so, when it was live.com and then eventually it was rebranded Bing, we were up against a brand and we were definitely losing. We were, Bing just was not doing well in the marketplace and we just did not have the search results that people expected. And in fact, if you look at from 2005 to 2009, the market share significantly declined. That little bump right there, I believe, is when they rebranded it one time, but then it went right back down to the decline that it had as it just continued to slide. And that slide was happening because our technology just was not up to snuff. And so some of the things that we did to solve it were around just changing our culture. But that's really a hard problem to do. First of all, we didn't call them data scientists at the time, but it was really hard to hire the right people to be able to do this kind of work, to really kind of do the analytical work that you needed to find. So we really kind of determined that lots of people needed access to data. If we couldn't hire the data scientists and we couldn't find the right, really smart people, why not just give everybody access to the data to find problems, find answers to problems? But to do that, is a huge technical challenge, and we really try to achieve that by building something that was right for them. And so from a new perspective, we looked at focusing on measuring relevance. We started looking at how can we give access to everyone so that they could do as many experiments as possible through machine learning. And we built a system that was an exabyte scale system that we called a data lake. Internally, we called it Cosmos. And basically, we gave tools that were approachable by any developer. So those tools were built on top of Visual Studio. They used languages that they were very accustomed to, like SQL and C#. And then we built machine learning tools internally, which made it easy for them to collaborate across those learning models. And we spent billions of dollars developing this infrastructure internally to be able to capture this big data solution. What that did for us is, over time, as they were able to experiment and determine what works and what doesn't work within the Bing ecosystem, our market share started doubling. So instead of a slide, which is oftentimes really hard to turn around when you start losing market share like that and you get into the single digits, you're usually pretty much done. But what they did was they fixed the underlying problems with Bing. They started making it better. The search results were better. The added features that they put onto Bing were better, to a point where eventually it started growing, and it's basically doubled in its market share over the last 7 years. So what does that do for you? Why do you guys care? Well, we went through a lot of pain to get there. We had a lot of learnings. We realized it took a lot of investment. We figured out how to get it right. And with that, with Azure, Cortana Analytics, we were able to bring you a system that we're going to talk about a little bit here, which solves a lot of these problems. And we basically democratized that system and made it available to our customers. So let's talk a little bit about what it takes to build your own data lake. And the slides get a little cheerier from here on out. So let's talk a little bit about moving from just landing data into the cloud, how to do intelligence on it, and then take action. Those are the 3 things you need to do. And the first thing you need for that is you need a big data store. We're going to talk a little bit about the big data store that we've developed and how you can go about using it and why it's important. But it's really the foundation for everything else that comes. Also, we'll talk about ingestion, and we'll talk about bulk ingestion and event ingestion. So when I talk about bulk ingestion, that goes back to that batch processing that we talked about before. Talking about bringing batch data in, landing it, and doing something with it. But beyond batch ingestion, eventually you want to get to a place where you're doing event ingestion. You're doing more real-time data. And we'll talk about that. And then we'll do preparation. So there's different tools that we can talk about that allow you to do preparation for the data. A lot of times that's ETL. You can also do analytics and machine learning. And there are tools that we'll discuss for that, so that you eventually can do discovery and visualization for the people. So if you don't make it available to your end users, to your business users, and to all those people that are asking those questions, then you're still being a barrier to them. And so it's very important that we provide these, not only the visualization tools, but also the ability for them to discover additional insights. When we talk about particular technologies, we're going to, generally speaking, look at this middle tier, looking at things like machine learning, data lake analytics, HD Insight, some stream analytics on top of data lake store, and how these different tools can be used to provide you insights or your users insights into your data using some of the visualization tools like Power BI and SQL DW. All right, so let's talk a little bit about Azure Data Lake. And this is the team I actually come from. So if I spend more time on this than some of the other tools, you know why. So this Azure Data Lake is the system that I was just talking about that was built off the system that we built internally. And really what we've done here is we've basically separated data and compute. And this is very important when you talk about cloud-based scale. And so we'll talk about the Azure Data Lake store on the bottom a little bit, and how you can use that to store your data of any type, of any size for your analytics. And then on top of that, we have, sitting on top of a yarn-based cluster, the ability to either do job-based analytics on the left or cluster-based analytics on the right with HD Insight. And HD Insight's been around for a few years. You've probably heard quite a bit about it, or you're using it today. So we'll touch on it and point you in a few different directions about how HD Insight, our Hadoop-based cluster-based service, can help you out. But we'll talk a little bit more about the analytics job service on the left, which is relatively new and does some different things that we do based on our experience internally. So let's talk a little bit about a data lake store. So what do you need if you build a data lake store? Well, of course, you want it to be secure. When we go talk to customers, the first thing they ask us is about a dozen different questions about security to the data. Because they want to know that if I build this, if I put my data into your cloud, will it be safe enough? And we'll talk a little bit about that, but the answer is we've thought a lot about this. We've put many measures in place to make it as secure as possible, and we believe it solves some of those problems. It also needs to, of course, be reliable. It needs to, the screen down here doesn't read very well. And of course, it needs to be able to do things like allow you to store your data in any format. And this is important because a lot of data stores force you to put the data into certain formats. By being able to put your data into there, if it's a CSV, if it's ORC, if it's Parquet, if it's JSON, XML, it doesn't matter. You can store the data in the data lake store. It's basically a file and folder system like you're used to, where you can just basically create folders and put data into those folders, and then basically put the security on top of those folders through Azure Active Directory like you would expect. And then it needs to be accessible from multiple analytic frameworks, and we'll talk a little bit about that. So Azure Data Lake Store is the system that we built that is an HDFS file system for the cloud. It has web HDFS as its interface on top, and it allows you no limits to scale. And what that means is you can have files as big as you want, and we've put a petabyte-sized file in just to show that we could. I don't know what the usefulness of it is, but you could do that if you wanted to. Or when we say no limits to scale, that also means you could literally put millions upon millions of files in there also. So there's no limit to the size of data. You could have petabytes upon petabytes in one store account, and there's no limits to the number of files you can have in there. Like I talked about, you can store any data in its format that you want to, and it has enterprise-grade access control. Things like access control, it has encryption at rest and encryption during movement by default. The access control is a POSIX-based system that you can use to basically give read, write, and execute access. At the folder or file level, you can use Azure Active Directory, so you can assign groups to different folders. It basically allows you to treat it like any other store that you might have been used to on-prem. And then finally, it's optimized for analytical workloads. What does that mean? It means the bigger your workload, the more likely you're going to see good performance. The bigger the workload gets, as you get into terabytes and terabytes of data, and you start hitting it with dozens or hundreds of nodes from either Hadoop or Data Lake Analytics, the more impressive the performance is going to be compared to something like blob storage. If you want to know a little bit more about Data Lake Store, there's a session from Sachin later this week that you can take a look at that session and find out a little bit more about how to put data, how to secure it, how to put data into it, all that kind of stuff. On the left side of that screen earlier, we talked a little bit about Azure Data Lake Analytics. So this is a job-based service, a job-based big data service that allows you to basically write some code in what we call useSQL, which is a combination of SQL and C#, and basically deploy that against your data sitting in Data Lake Store in a job service. You don't have to run a cluster, you don't have to build a cluster, you don't have to configure a cluster. You literally write your code and you deploy it out to the job-based service. And all you do is, when you deploy it, is tell it how many vertexes do you think you want to run it on, or that you want to run it on. Is it going to be 5 vertexes, or is it going to be 500 vertexes? And basically, at runtime, we'll deploy the containers in Yarn for you and run that job, and then shut the job down and destroy all the vertexes when the job is complete. What does that give you? That gives you the ability to focus on business goals and not configuring hardware. And when we talk to customers, this really resonates with them. The ability to just use a language that you probably already have experience with, SQL, add some extensibility to it with C#, which basically allows you to do anything you want to with the data, and then use tools that you're used to, like Visual Studio, to debug the data, debug your code, and then just deploy it when you're ready to deploy it. One of the things that's not on the slide that's actually really useful from a big data standpoint for Azure Data Lake Analytics and useSQL is the ability to do local debug. What that means is you can take, let's say you have 100 terabytes of data sitting in the cloud for a particular job you want to run. You can take 10 gigabytes of it, bring it down to your laptop, put it in a folder structure, and point the jobs at that, and do local debug of your code to get it working before you deploy it out to the job service. What that does is mean you can run it for free locally. You can debug it in a relatively quick fashion as opposed to waiting on it to fail against terabytes of data. It's a really nice developer experience, and developers love using Azure Data Lake Analytics. Again, you also have enterprise-grade role-based access control, just like you did for Data Lake Store. Also within Data Lake Analytics is the ability to query data where it lives. So while you have Azure Data Lake Analytics and you have a lot of your cloud-based data or your logs or what IoT data sitting in Data Lake Store, and you're using Data Lake Analytics to do something over it, a lot of times you want to bring in data from other stores at runtime. The canonical example I use is when you have something sitting in SQL DW or SQL DB, like a conformed dimension, maybe a date dimension or your customer or product dimension, this is a really good opportunity to bring that data in through a USQL query by just basically treating it like an external data source and bringing it in to augment the data in Data Lake Analytics. This really, as you're doing ETL in Data Lake Analytics, this really allows you to not have to move a bunch of data around, but actually go get the data at runtime, bring it in, use it. When you're talking about maybe doing ETL against terabytes of data in Data Lake Analytics, going out and grabbing a few gigs of data sitting in SQL DB or SQL DW is a relatively cheap exercise on our part. It doesn't really add a lot of time to the query when you're talking about big data queries. What this allows you to do is access all that data sitting in these other data stores, still using USQL, and really just kind of minimize the data proliferation issues you might have by copying data everywhere, because you can leave the data where it resided. Yes, sir?
Go on an earlier slide, you've got Azure SQL Data Warehouse as a visualization tool.
Yes.
But there you're kind of presenting it as a source, aren't you?
So the question is, in an earlier slide I had Azure SQL Data Warehouse as a visualization tool, and in this case I have it as a source. The answer is it can be both. And I'm not trying to be cute with that answer. The answer is you might have a conformed data warehouse you already have today. Maybe it's sitting on-prem that you haven't moved to the cloud yet, and maybe the first step in your journey to the cloud is taking that data on-prem and copying it up to the cloud and keeping a copy in both places. Why would you do that? A lot of customers are doing that for bursting to the cloud. Maybe you have an appliance on-prem that has really kind of already hit its limitations of how many users it can access it or how much data it can hold. And so one of the things that customers are doing is creating processes to take a copy of the important data that people want access to, putting it in the cloud, and letting people query that. So the new users and new groups that are coming in, point them to the cloud instead of to your on-prem appliance. That's step one. Step two would be start loading directly instead of to your on-prem appliance and then eventually the cloud. Why not load to the appliance and the cloud at the same time? And then step three eventually might be just load straight to the cloud, and you can get rid of that really expensive appliance and just deal with your data sitting in the cloud, where now you don't have to worry about data sizes, what have you. So now what I'm talking about there is you might have conformed dimensions in that particular data warehouse. And in that case, those conformed dimensions can help inform ETL being done or other analytics being done within your big data solution like Azure Data Lake Analytics. On the other hand, Azure Big Data, something like Azure Data Lake Analytics or Hadoop are really good at doing things like ETL. So once you've done all that ETL work and stuff, they're not as good as doing interactive dashboards for your end users. And so a lot of times what users do or customers do is they take that data and they move it to something like SQL DW. So in this case, this might be an ETL job that is designed to bring data to your SQL DW, but you're using conformed dimensions out of SQL DW to augment that data before you bring it into SQL DW. So that way it has like all the right keys and everything that you might need for your traditional data warehouse. And I'll talk a little bit more about SQL DW in a little bit and how the two complement each other quite a bit. So to the usage scenarios. So I talked a little bit about some of the load, extract, transform, and store. That's a little different than ETL because in the cloud-based system, first thing we got to do is load it into Data Lake Store. Then we can extract it, we can transform it, and then eventually store it for analysis. A lot of times we want to cook that data for other users, so the let's and share. So that might mean you cook it, and then it goes off to 3 or 4 different data warehouses or DBs for different kind of analytics and end uses. And then augment the big data with high value data. That's what we were just talking about, which is augmenting that big data with the high value data you might have, like your product information sitting in your data warehouse. If you want to know a little bit more about uSQL itself, Michael Reese is doing a session on Thursday at 9 a.m. Well, he'll be talking in detail about uSQL and what it means. A complement to uSQL is our commitment to the open source world with our Azure HDN site. And that is our fully managed Hadoop and Spark for the cloud clusters, all based off of Hortonworks data platform. So basically what we've done is we take the Hortonworks data platform, we turn it into a PaaS service, which allows you to spin up clusters in minutes and be able to use them. There's some more detail about the HDN site clusters. If you want to know more, you can go to Rashim's session on building big data infrastructure using Azure HDN site. Let's talk a little bit about what you can do with those kind of things. And here's an example of a customer, Virginia Tech, which is using HDN site to handle data. So before they moved data in the cloud, they had their own clusters of data where they were dealing with doing genome sequencing. And what they realized pretty quickly as the genome sequencer started generating up to 15 petabytes of data per year, they really couldn't stay in the business of building clusters to deal with data. So they came to us and we worked with them to help them move their solutions to the cloud using HDN site to process that data. What they do now, what used to take them, one sequence used to take them 2 weeks to do, they can now do 100 sequences in a day with the cloud because they can burst with the cloud to do that work. So that's really just dealing with a large amount of data, being able to store it in a store, burst up using something like HDN site to deal with the data at scale. And then when they're done with the sequencing, they can just shut down the clusters and not have to worry about paying the cost of the cluster at that time. Let's talk about some new things for HDN site, which I think is more interesting than talking about HDN site in and of itself. This week, we will be announcing that Spark 2.0 is available on HDN site, and I'll give you a session to go to later on this week that talks a lot about the different options that are available with it. But basically, this will allow you to do, Spark 2.0 is like 10x faster than the previous versions of Spark when it comes to performance on HDN site, and also the SQL syntax has gotten much more first-class citizen within Spark. So if you're looking into Spark, if you haven't looked into it yet and want to look at, Spark 2.0 might be a place where you want to start as opposed to starting with some the previous versions. Also, it's also optimized for our Jupyter notebooks. So if you go to notebooks.azure.com now, we have Jupyter notebooks available to use with the Spark clusters. And it gives you a native notebook experience for your data scientists. Also, all that Spark 2.0 is integrated with the batch pipeline, so you can use Azure Data Factory to orchestrate Spark ETL jobs. You can use Power BI now to connect with Spark. And there's some more detail there on the slide about where to go find some more information about that. I would highly recommend going to the session later this week if you want to know more about Spark, as Maxim will deep dive into the Spark features. Let's talk about something else that's coming this week, which is deeper enterprise-grade security with HDN site. So a lot of times, like I said before, when it came to the store, one of the first things people ask us is a lot of questions about what does it look like for enterprise security. Let's first talk about we have perimeter level security. So we have virtual networks, which will basically allow you to define what networks are accessible to your Hadoop cluster. We also have this gateway service, which is very similar to the Apache Knox, which basically allows you to continue further define and accept and request and validate any job before it actually gets submitted to your Hadoop cluster. So that allows you to do Active Directory authorization before it even gets to the Hadoop layer. Also, we have the multi-user authentication, which is new as of this service, which allows you to have multiple users within your Hadoop cluster. It also uses Kerberos and Azure Active Directory now. We also are announcing that authorization for Apache Ranger. So you can now have Hive and HBase policies that allow you to basically define file and folder access for your ACLs on ADLS. And then finally, data security, of course, the encryption at rest supported, both for Azure Storage Blob and ADLS. So the different layers of security, and some of those are new with the new release that's coming out later this week, really give you the comfort that the data that you're putting in Hadoop allow you to basically give you top-down security on top of this, by-the-side security at the ADLS level. And there's a full session on security on Hadoop later this week also if you're interested in more about that. Also, announced for later this week with the release is Hive LLAP. Who's heard of Hive LLAP here? Nobody. Who's heard of Hive? Okay, so this is important. This is really important because this is a game changer for Hive. LLAP is the ability to basically do in-memory compute for Hive to significantly improve performance. Hive is very popular with a lot of crowds because it's very easy to write against. It's very native for SQL developers to jump into. It is basically a Hive SQL-like language, but it has been notoriously slow. And everything the community's been doing over the last 5 years is basically trying to make Hive faster. And every release of Hive always has something like we're 5 or 10 or 15x faster. And this is another case of the last version of Hive got pretty good, but it was still slower, and especially when you compared it to something like Spark. But then again, Spark has other languages that you have to learn, has a different modeling that you have to understand. So the Hive community continued to double down. And what this means is basically using in-memory compute now within your cluster, they have significantly improved the performance of the Hive queries. This allows Hive to become more of an interactive environment, which it never was meant to be when it was originally conceived of 7, 8 years ago, to a point where multiple users can now access it. You can use something like Power BI against it to really kind of get an almost interactive dashboard feeling. This really changes the game for developers and for Hadoop, people that want to use the native Hive experience. So I would definitely recommend checking that out if you're interested in looking at what Hive can do on top of Hadoop. Because all your BI tools like Tableau and Power BI have all been kind of integrated with Hive for a good long time. Talk about another customer story and talking about what Hadoop can do for a customer, especially when you talk about more interactive and real-time dashboards. This is a case of Jet.com, which was actually just acquired by Walmart, has been using the Azure Stack for quite a while. And it's actually built entirely on the Azure Stack from its original inception. What that has allowed them to do is allows them, with no servers on site at all, not a single one, develop queries that allow, when you put data into or you put items into your shopping cart, they can basically analyze your shopping cart, compare to other shopping carts and against their product inventory, and change prices on the fly. And they use that using technologies within Azure, like Azure Machine Learning and HD Insight. And to be able to do that, they have to use HD Insight to really kind of crack against a large data set of all the inventory and all their customers and all the previous products that have been used, so that they can give you kind of a shopping cart price depending on what you're putting into that shopping cart. It's a really interesting service. And within each one of these slides, when you download them, there's a link to the customer case story to find more. This is a case of a customer thinking differently. And that's one of the reasons why I wanted to talk about it, because this is when you think about data, this is really the important message to get across is you need to think differently about your data. What else are you doing with your data? What else could you be doing with your data? What other sources could you be bringing in? Because it's the customers that are thinking differently about their data that I find can be really interesting. In this case, this is a case of, you think of a shopping cart being a fairly static activity, but they turned it into a streaming activity. And that streaming activity allowed them to differentiate themselves so much that they're two big competitors. The guy that built Jet.com had previously built another solution that was built by Amazon. That was bought by Amazon. And then this solution was just bought by Walmart. His competitors obviously saw that the things he was doing was worthwhile and wanted to take in his solutions, or at least get rid of the competition. But these kind of real-time scenarios, these kind of streaming scenarios, kind of lead up to what you can do. This should be one slide off. What you can do with a streaming analytics solution. So I've talked a little bit about data lake analytics and HD Insight sitting up there in the preparation analytics and machine learning. And that's kind of the base of let's get to better batch, faster batch. The streaming part is the important part. And let's go back to what Azure Streaming Analytics can do also for you. So it's a PaaS service sitting on Azure. with zero upfront costs. You basically can set it up and get it going within a few minutes. You basically can connect out to things like event hubs or to your data lake store to be able to bring data in. And then it can push that data out to different services also, including Azure Machine Learning to be able to score the data as it's coming in as a streaming service. And it allows you to do different things with the data. Some of those things, this is getting back to thinking differently about your data. Whether or not you can think about real-time detection fraud, and that can be from a website point of view, or that could be from a looking at your credit cards or something else. There's lots of things where real-time fraud detection can be really important to an end user. Clickstream analysis, real-time patient monitoring. We have lots of customers in the healthcare space that are looking at how can they get into not looking at the data every time a customer comes in, but how can we start getting real-time data about those customers? You've seen case studies around smart grids from customers. I think, who was it? Joseph gave us a study last week, or not last week, yesterday around the smart grid from Schneider Electric that is really interesting about bringing data in from solar panels. And then a lot of customers are looking at real-time demand and inventory management, which is different than, let me go back to that because that's pretty important, which is different than your standard, let's just deal with my inventory management on a daily basis, but really know as data comes streaming from stores, can I figure out whether or not I'm going to be low on a particular product by the end of the day and do something about that? An example of a streaming platform is the company Ziosk that has these machines that you see on a lot of tables sitting in restaurants. Chili's is an example, Applebee's, Red Robin here in the States are a few different examples of these kind of devices that sit on your table. Usually, when I first go in, a lot of times I do is pick them up and move them, right? Because they're in the way. But a lot of people, especially if you have kids, they use them. You can use it to interact with the menu and other things about the store. And what Ziosk does is tries to use the data that as you're using that in real time to offer you an experience that might be a little different. So they'll offer you different coupons or what have you to try different things. So based on your experience, what you might be clicking through the menu, whether or not you're looking at the appetizers, how you're looking at the appetizers, based on their experience of how other people have interacted with that, they will give you, they use that data as you're clicking on it in real time to give you different coupons and different experiences within that to try to optimize your experience. And so to do that, you can use something like Azure Streaming Analytics, which is fully managed, it's enterprise grade, and it's developer friendly. And I'll talk about a little bit about what those mean. The fully managed part is pretty easy. It's managed by Microsoft so that you can have a hyperscale analytics solution. What that means is you can get up to millions of events per second, add all sorts of incremental resources to scale so you can go out and get some of your data sitting in your SQL DB on top of that streaming data coming in so you can augment it and send it downstream to another solution. We have data centers all over the world to be able to handle those kind of events. Of course, reliability and compliance. The reliability I'll kind of whitewash over, but we have all the compliance that you would need to handle your data as it's coming through the streaming system. And then I think this is more important, which is the powerful analytics using SQL constructs. There are several different streaming solutions that you could choose from. Not all of them use SQL. And I think this is the key where you're seeing this throughout a lot of our products. We're taking the power of the user base out there, people that know SQL, and giving them access to different technologies. And in this case, the access to be able to use SQL within a streaming analytics solution makes it more readily accessible to your developers so that they can get up and running. And to do that, what we've had to do is we've added additional user-defined functions and extensions so that they can easily set up the right streaming analytics questions that you need answered to push downstream. And I talked a little bit about the integration upstream with things like Event Hub and IoT Hub or pulling from blob storage. You can reference data either by scoring it out to machine learning or reference data out of the blob storage or SQL DB. And then eventually you can egress it out to a live dashboard sitting in Power BI or driving other additional workflows. So when we talk about live dashboards for Power BI, that's getting us farther up that right-hand quadrant that I talked about earlier, right? And so this is where looking at how can I take the data that I have and add streaming to the solutions. And of course, there's built-in monitoring so that you can kind of monitor the solution. A good example is NEC. They built a solution that basically allows them, through video, to do facial recognition of customers in stores to determine if they're male or female, and also approximate their age, so that each store can have real-time analytics on what are the demographics of the store at any given moment. And using that information to do special offers or special whatever they want to do with that information. This is the case of, with that real-time streaming, scoring it machine learning, pushing that back out to the stores through an interactive dashboard, and then using that information to basically decide whether or not there's some sort of promotion they might want to run in store at any given time. Really kind of drives a differentiation for the stores that use a service like this. Another retailer that I know of, which has lots of stores in the US and around the world, they typically have lines for people to come in and buy things, and they have video within those stores, and they basically measure what is the average line for that store in any given day. And they use the same kind of streaming analytics to do that, so that they can see that, hey, this store has an average, the line's usually an average of 3 or 4 people long, but today it's been 7 or 8, why is that? So that they can ask questions, or so the manager can figure out what they needed to do, or they might be able to react in a more real-time fashion. Being able to think about data, not just your data that you're creating by human generated, but what else other data does your organization produce? And what could you do with that to make it a better product for your customers? What's that? Are they profiling the customers?
Yeah, so
In this case?
If you've got a queue, how many are men, how many are women, what's the estimated?
I don't believe so, no. I don't know the answer to that, but I don't believe that's what they're doing. I think at this point they're just trying to look at what is their queue. Because that's an important information. If you're a store that it basically relies on queuing so that people have time to figure out their order, but you don't want the queue to be too long, you want to find that easy balance. And I think that's what all they're trying to do at that point. But to your point, I think like this NEC solution, I think that's where you go. Would it be a more interesting solution to start profiling based on age or what have you? Because then you might be able to do something different with the store. Maybe the store music changes based on the age of the people in the store. Those kind of things could certainly be where we're going. If you want to know a little bit more about Azure Streaming Analytics, there's a session later this week by Sam on how to gain insights and predictive insights on your Internet of Things. You can take a look at that. So let's talk a little bit about farther to the right, which is the SQL DW side. And I've talked a little bit about how SQL DW and Azure Data Lake or your big data store can kind of interact together, but let's jump into a little more detail. Because I think it's important to talk to it at this point, which is I think big data is part of data warehousing. I think they're complementary. You need both to be successful. If you just have big data without a data warehouse, it's really hard to drive your operations. On the other hand, if you have a data warehouse without a lot of big data, you're probably missing a lot of insights in your solution. So when we talk about in the cloud, we talk about where data resides. If it's relational data, it probably resides in a SQL data warehouse or something like a SQL DB solution, or maybe even SQL on a VM, depending on what your needs are. If it's not relational data, it probably belongs in something like Azure Data Lake Store with Azure HD Insight and what have you. Let the shape of the data determine where the data resides. And this is important because if you're dealing with, let's say, a few hundred gigabytes of data, and that's all you have, and it's relational in nature, and it's sitting in a bunch of CSV files, or it's sitting in a database, moving it to Azure Data Lake so that you can do Data Lake Store, so you can do Azure Data Lake Analytics on top of it, you might be disappointed with the results because it's not designed to deal with small amount of data. SQL Server, SQL DB, has been around for 20 years, and it has been purposely built to handle relational data really, really well with the indices and everything else it does. So don't try to force everything into the new thing. Try to find the right place for any particular side of data. On the other hand, if you're dealing with terabytes upon terabytes of JSON data, trying to force that into a SQL data warehouse is pretty painful. And there's better ways to do it. And the better way to do that is store it in its native form in something like Azure Data Lake Store. Use something like HD Insight or Azure Data Lake Analytics to process the data. Get some of the pieces out of that you might want to put down in your SQL data warehouse and turn it in a more relational form and put it in your SQL data warehouse, but leave that data sitting in its original form because some of that data that you didn't put in your SQL data warehouse today might be useful for you tomorrow. This is another way I like to think about it, and I put this together to kind of just help people kind of see when to use a data lake and when to use a data warehouse. You know, data lakes are schema on read versus the data warehouse is more of a schema on write. What that means is, you know, schema on write means we have to define the schema before we put any data into it. Defining a schema for a data warehouse can take a long time to do in some organizations. I was in one organization where it literally took us months just to decide on what fiscal date meant because different groups within the organization thought different things about it. And so when we're fighting over that, other people can't wait for that data. So that's where schema on read becomes really useful because just put the data down and then on query time you can define the schema. Oftentimes what you'll see is the data lake is really good for data discovery because all the data is there, all the detailed data is there, where the data warehouse is really good for data reusability. And by that, what I mean is you can put the indexes on it, you can put statistics on it. It is very interactive so that you can drive reports like Power BI and what have you. So Azure SQL Data Warehouse, talking a little bit about it. You know, it's really good for those near real-time analytics over structured and some unstructured data. The reason it can do some over the unstructured data is because of a technology called Polybase, which allows you to create external tables sitting on that data sitting in blob storage and in the very near future over the data sitting in your Azure Data Lake store. Of course, all the tools you're used to using like Power BI and Tableau are available there. It allows you to basically scale in seconds, right? So the thing about SQL Data Warehouse is you can scale out the number of nodes from just a few to several dozen so that without having to worry about how to program across those nodes because you get a single user interface for your SQL. That is really the innovation there that allows you to really scale as your data scales by, again, kind of dealing with that decoupling of your storage and compute. You can pause SQL data warehouses, which can be an interesting feature for those systems that basically only need their data warehouse for a particular time of day, let's say business hours. This becomes really useful in the world of merging your big data system like Azure Data Lake Analytics with your SQL DW. One of the reasons why we've had appliances that have been very busy 24 hours a day oftentimes is because we need nighttime to do a lot of the processing of the data as we do our ETL coming in. Because we use that appliance to do processing of the data and serving of the data up to our end users. Now imagine a better world in which we use two different systems to do that. Use a system like Azure Data Lake Analytics or HD Insight to process your data through your ETL, get it into the shape it needs to be in for your final tables, and just load it into your data warehouse. And then now your data warehouse can be just a server to your end users. And that is the ideal goal that I'm trying to help organizations get to. What this allows you to do is it allows you to size your data warehouse appropriately for just serving data to users, not for doing an ETL work, which a lot of times data warehouses are sized for ETL work, not what it actually needs to do, which is give data to end users. And so by separating out those two concerns, it can actually save you a ton of money. And it also allows you to really kind of tune your data warehouse, not for ETL, but just for the queries that are coming into it. And that's where you really can make your end users really happy. An example of a customer that's using SQL Data Warehouse and some of our other tools like HD Insight to do some stuff is around the intelligent buildings. And Carnegie Mellon's one, but we have multiple customers coming to us and talking about what we call intelligent buildings. Ambient sensors everywhere, dealing with things like temperature and light, air quality, security, all those kind of things. And really developing, in this case, they developed a lot of BI dashboards to be able to kind of monitor their buildings across the entire campus. College campuses, hospital campuses, other large organizations. Microsoft, being a large campus in Redmond, has a very similar solution. But also companies that do management of buildings. So think of companies that manage other buildings and strip malls and what have you for other people, or also looking at solutions like this, which basically take all that data, store it into Azure Data Lake Store as raw data, use HD Insight to basically turn that data in for ETL, dump it into SQL database so that you can drive some BI dashboards on top of that. If you want to know a little bit more about Azure SQL Data Warehouse, Matt Usher, who's a PM for that team, will be talking about that later on this week also. Actually, later on today. So what does that baseline architecture look like? You could have something as simple as this. So ingesting the data into something like Azure Data Lake Store, being able to do some preparation on it with something like HD Insight, allows you to do maybe some machine learning, and then eventually you can just push that out to something like SQL DB or SQL Data Warehouse for some Power BI dashboards. To me, this is step one to a lot of customers, which is let's just get the data from on-prem into the cloud, and then we can start augmenting some of that data by doing some of the ETL there in the cloud and making it available for our end users. And a lot of customers start with this basic kind of outline in step one so that they can get to something that's a little bit more interesting in step two, which is now you have data streaming directly into the cloud up there in the top left from some of your telemetry, maybe that's some logs or other IoT data, coming through some event hubs, going into streaming analytics. It's getting scored in machine learning. The answers out of that are being dropped onto Azure Data Lake Store. At the meantime, you're also bringing some of that data off of prem into Azure Data Lake Store. So something like HDI or Azure Data Lake Analytics can do some of that churning, again, some machine learning scoring. So eventually you have those predictions coming out of Azure SQL. And then you can also down there at the bottom just have a straight big data pipeline also. Some additional data going to Data Lake Store. Something like Data Lake Analytics is available to do some of that processing, allow your data scientists direct access to that data in a job service like Data Lake Analytics, so that it can eventually be pushed out into something like Azure SQL also. And now you can have a Power BI dashboard across all those things. Step one is a good place to get to. You can never get to this step here where this is a much larger, more integrated system unless you start with step one. Who here is dealing with data sitting in Azure today? A few people. A lot of people are trying to figure that out, like what's the first step? And we talked a little bit about that before. That first step is going back to this solution of let's look at how we can augment our current systems, provide new answers or new questions to the data so that we can kind of augment for maybe a new set of users. A lot of times this can be, okay, we want to use the same data that we had on-prem, but we have some new requirements coming up. Instead of having those new requirements go against that data that we already have, let's bring that data to the cloud and start building up those new requirements in the cloud as we get used to learn the technology. From there, once you have that, that's when you can start adding one thing at a time on top of that by adding the streaming and other additional functionality as you start getting more comfortable with some of the solutions. And that's a lot of tools for your toolbox. And I didn't even touch on all of them because there's too many to go over. When you talk about streaming, I talked a lot about Azure Stream Analytics, but we could easily talk about Spark streaming if we wanted to, or Storm, which is available in HD Insight. When we talk about the batch services around HD Insight, we talked a little bit about Hive, but you also, obviously have Azure Data Lake Analytics, or you could build up your own cluster sitting in Azure IaaS against that data sitting in Azure Data Lake Store if you want to. There's a lot of tools in the toolbox. The question isn't which tools to use. The question is, what do you want to do with them? And that once you figure out what you want to do with your data, then the tools become more obvious. And that's how one of the things that I try to take away from having these discussions with people is, don't sit there and come away with, okay, I went and I learned these 3 technologies, we need to now go implement them. But it's better to go the other way, which is, what are my business solutions I'm trying to solve, and which technologies help us solve them? And then kind of working your way back down into that. All of these tools that we built over the last couple of years have allowed us to basically be recognized by Forrester this year as a leader in the cloud when it comes to big data. So that you can see that our strategy is starting to pay off because we're not focused on one technology or another, but we're giving you choices in the cloud, and those choices make it harder for you, and we get that. Because now you have to choose, which do I choose, Azure Data Lake Analytics and use SQL, or do I choose HD Insight? And why would I choose one over the other? And that can be a long conversation that we can have. Instead of just giving you one choice and saying do everything this way, we try to give you choices, and then we try to guide you based on the requirements of a particular application, which one you should use over the other one. And all those choices allow us to really kind of really move up in this quadrant where we were way down 3 or 4 years ago, down into not even being much of a player in this space, to being now a leader in this space, not only in our ability to have our execution of our current offering, but where we're planning on going with some of these technologies in the near future. So I've left about 10 minutes for some questions, if you guys have any questions about any of the particular technologies. Otherwise, thank you for coming.